In college algebra, we wrapped up systems of linear equations. On Wednesday, we stopped right before a really ugly problem, and that's on number 4. So let's see if we can do this thing. It's ugly because it's arranged weird, and we get ugly numbers. So first off, you need to line up x's, y's, and the constant. That's if you're doing elimination. If you want to be a rebel and do substitution, you are welcome to, but I think it's worse because you get more fractions. All right, I want to line up x's, y's, and the constant. I'm going to go in this form: x, y, constant. So that means in equation 1, I need to get y on the left side. So I have 2x minus 7y equals negative 17. In the second equation, I need to get that negative 3x on the left side. So it flips its sign to positive 3x plus 5y equals 17. And then double check, you flipped the right signs and it all looks good. We're all lined up. Now you pick a letter. I'm going to pick X to cancel. Let's make X cancel. That is totally up to you. So I see that 2 and 3 have a common multiple, or I know 2 and 3 have a common multiple of 6. So if I multiply this equation by 3 and this equation by negative 2, they'll both become 6 and negative 6, and the x's will cancel. So I'm going to rewrite the first equation right here, and I get 6x minus 21y equals negative 51. So I just distributed the 3. Next, distribute the negative 2, and you get negative 6x, negative 10y, and negative 34. All right, this thing is ready to go. When I combine these two equations, the x's cancel. I get negative 31y and negative 85. Unfortunately, those are not divisible, and y is 85 over 31. All right, we have the Inspire, so we're going to use it a lot. I'm going to plug 85 over 31 into the second equation. So I'm going to rely on the Inspire on this problem. I go 5 times 85 over 31, and I get a rough number, 425 over 31. Now I need to solve for x. So I'm going to stick with the Inspire. I'm going to subtract 17. And I get negative 102.31. Whoops, I just lost all the ink I was using. There we go. And now I've forgotten. Negative 102 over 31. And divide both sides by negative 3. And 34 over 31. right, very ugly numbers, but we lived. It's all okay. All right, on the back, we have some different scenarios. The typical one on the front of the page is the third scenario right here. That's what we're used to. But there are other scenarios. What if we have parallel lines? They'll never cross. That's no solution. What if one equation is a multiple of the other and they're actually the same equivalent equation? That means there's infinite solutions. So the way this plays out is on the first two scenarios, all variables cancel. And you have a false statement. These are going to look really similar, these two scenarios, and how it plays out. In this one, all variables cancel again. And you have a true statement. So let's see. 5 and 6 will be one of each of those. So on number 5, I would do elimination. And I pick that because all the variables are lined up. I see the x's, y's, and constants stacked above each other. Now just pick a variable. Let's make x cancel. So 4 and 6 have the common multiple of 12. If I multiply this by 3 and this by -2, I'll get 12x and -12x. And I'll be able to do elimination. So 12x plus 18y equals 36. -12x, -18y, -24. We're ready to go. The 12s are going to cancel out. But look, the y's also cancel. When that happens, double check that you didn't mess up, but we didn't mess up. So just write what the result is. We have 0 on the left side. On the right side, we have 12. And does that make any sense? That's false. This is no solution. Let's try number 6. I would use substitution on this one. All because of that y being set equal to, like solve for. It's all by itself. So that means I can take this and plug it in right there. And it's a pretty quick problem. So 4x plus 2, substitute 3 minus 2x in place of y, equals 6. 4x plus 6 minus 4x equals 6. And sure enough, the x's cancel again. But this time I have something that makes sense. 6 does equal 6. That is true. So infinite solutions. All right, we had one more thing. We have a big word problem. We are looking at a company that sells and makes wheelchairs. So there's a lot of terminology on this one. Maybe hit pause and skim the paragraph. When they talk about cost, this is from the company's perspective. So this is not talking about the customer's perspective. And that's where people get mixed up. Cost is how much let's write that on the next line. It costs to produce wheelchairs. This is not what the company, this is not what the customer is aware of. So the revenue is what the customer is aware of. Revenue is how much the company brings in. In other words, what the customer pays. Terminology on this one is killer. You could understand this scenario perfectly, but get A and B wrong. Many students will get part C correct, but then they'll totally mess up A and B. So A is asking for the function cost, what the company is out of pocket getting this company started. So they have to pay $500,000 to start plus $400 a chair. That's how much they have to spend. Now they want to make a profit. They're not just giving away these wheelchairs. I mean, maybe someone can afford to do that, but this company is going to charge. So they do want to make a profit, or else why are they even in business? So they're going to charge the customer $600 per wheelchair. And that's our cost and revenue functions. So the break-even point is where cost equals revenue. All you have to do, it's very easy, is set the equations equal to each other. So all you do is you say 500,000 plus 400x equals 600x, and you solve for x. That's the break-even point. Like, that's the number of wheelchairs they need to sell to get out of debt. So you move 400x to the other side, and you have 200x. Divide both sides by 200, and you have 2,500 wheelchairs. And that's it. That gets them out of debt. Kind of sad. 2,500. They haven't even made money yet. All right. You have a good day. See you later.